So what we're going to talk about is multiplicity of roots with respect specifically to talking about X-intercepts. So talking about real roots here. Okay, so you should have your attachment, okay, your notes for today out with you. Hopefully you were able to print them out, okay, so you can follow along. This is all on your attachment. Okay, this is under part 2, X-intercepts of polynomial functions. So first one, okay, f of x equals x plus 4. And part A says, what is the x-intercept? So there's only one x-intercept here, right? It's -4. And now what is the behavior at the x-intercept? So if we zoom in, right, if we were to zoom in and zoom in on that x-intercept, it's just going to look linear there, right? It's just going to look like we went straight through. Okay? We went straight through. If we were below it before we hit the intercept, after we hit the intercept, we're now above the x-axis, okay? And number 2, okay, look at number 2. We have f of x is x squared plus 8x plus 16. It's factorable. It factors to be x plus 4 times x plus 4. Okay, this is a quadratic, but how many x-intercepts does this have? This only has one x-intercept of -4, but the behavior is very different between this and this. And the behavior is extremely different because how many times do you have the factor of x plus 4? You have the factor of x plus 4 two times. Two times, okay? And if we zoom in, if we were to zoom in on that factor, what are we going to notice? I'm sorry, at that x-intercept. What are we going to notice it looks like? Okay, it looks like a quadratic there. Okay, what's the behavior at that quadratic if we were to zoom in? It hits when y is 0 and then it goes back up. Okay, or if it was coming from down, it hits and goes back down. So I refer to that as a bounce. Okay, if I was to zoom in, it has a quadratic look to it. Now, this, I had a single root of -4. This time, I had a double root of -4 because I had the factor x plus 4 twice. Now, in the third, you have x plus 4 times x plus 4 times x plus 4. So this polynomial is x to the third plus 12x squared plus 48x plus 64. But how many x-intercepts are there? There's only one x-intercept, but how many times did you have that? You had it 3 times. This has a triple root of -4. And if you were to zoom in, right around that x-intercept, it's going to look like our cubic function, okay? That's because you have x plus 4 to the third power. And we talked about why a cubic takes the behavior that it does, right? It changes signs because what's positive stays positive and what's negative is negative. And it goes really fast because when you are 1 unit away from the vertex, okay, when you're 1 unit away from that root, you're growing really slow. Once you get further than 1 unit away, you're going to grow really fast. So it kind of like squiggles right there, okay? So if we wanted to describe it best, it would look like a cubic, but what it does is it kind of like levels off and then bounces back up. So I just use the word levels. If you want to use squiggle, snake, however you want to describe it in your own words, what's happening, okay? That's what's going to happen every time you have a triple root. So when you have a single root of -4, which means you only had x plus 4 once, it's going to look linear through the root. Okay, if you had the same factor twice, that means you had a double root of -4. It's going to behave like a quadratic. Okay, if you have a triple root, the root is going to behave like a cubic. So if you take a look at the next page here, number 4, notice in g of x, the top left, x plus 4, x plus 4, x plus 4, x plus 4. That's the same as x plus 4 to the 4th, right? X plus 4 to the 4th. And notice what it looks like. Okay? It looks extremely similar to the double root, but this is actually a 4th root of -4. But it's taking on that same behavior of this bounce, because if you're raising it to the fourth power, okay, whether or not you're positive or you're negative, you're going to output the same thing when you raise it to the fourth power. And then if you look at x plus 4 times x plus 4 times x plus 4 times x plus 4 times x plus 4, which is x plus 4 to the fifth, okay, it looks almost identical to the triple root. Okay, that's because this is actually what x to the fifth parent, if I shifted this back over, would look like. It would look very close to being a cubic, except, okay, when you are within 1 unit, you're growing even slower, but then when you're 1 unit away from the vertex, you're growing even faster than to the third power. But notice, it takes on the same behavior at the root. So it says in part 4a, says, what is the behavior of a root with multiplicity 3 or 5 or 7, which is also depicted? It's all going to look like a level. Then in b it says, what is the behavior of a root with multiplicity 2 or 4 or the other picture 6? It's always going to look like that bounce behavior, okay? So this is what the behavior of roots or X-intercepts are going to look like. So now we can start graphing, because now we know about end behavior. Now we know about roots and their multiplicity and how their behavior changes based on how many times you have the factor. So now we're going to start graphing.